whenever you guys are
Just
ready.
keep in mind that the laser stuff I had to move from the...
Can you tell me about this contraption?
Yes. So here's our auto-targeting nerf gun. There are a few things that go into this. So first we have a servo motor, and we're controlling that with GPIO pins and a PWM output, and we're moving it around. We're basically sweeping about like a 90-degree area. And then we have this laser sensor, and that's sensing the distance of objects in front. It's right here, and it will sense whatever's in front pretty accurately up to about, I don't know, 1.4 meters.
Okay.
And then to finish off, there's also a DC motor, which goes with this pretty big gear ratio. It's about 500, and that is able to pull this trigger using a wire. There's a wire running through it, and then there's a wheel getting powered by the DC motor to pull the trigger.
Okay, so DC motor is here, interfaced with this first gear.
Yes.
And then there's a whole gear train to increase torque to pull on that thing. Okay.
One interesting thing actually is that this Nerf gun originally required so much torque that like if we tried to put it on this tiny little servo, it would just like collapse under itself.
Okay.
And so what we had to do is to sort of like reconcile that is we needed to like take this apart and like shave down the triggers so that like it didn't require as much torque.
Okay.
And we could actually fit it on with like a tiny little gear ratio.
Yes.
Okay.
Yeah.
So you made the trigger easier to pull.
Yeah,
by-
there were a lot of like physical constraints that needed to be taken into effect here.
Okay. Cool. And then the expected behavior is that it searches for a target?
Yeah.
Okay.
It searches for a target, and what it does is it captures the first edge, and then it'll continue going until it finds that, I no longer sense anything, so it captures the second edge, and then it should center,
Okay.
right?
It's a
And then,
state machine.
yeah, it's basically, we use a state machine to do that, and then
Okay.
it should yield for a little bit so that it doesn't just start sweeping again.
Okay.
But then eventually, ideally after the trigger is pulled, you don't really need it to do anything, but it will continue sweeping again after you move away.
Okay.
But it is there's some there's a lot of like optimization. There's like parameters that we need to sort of like adjust in order to get this thing properly working
Sure.
as expected. But yeah, I guess we could.
Cool. So maybe
demonstrate.
could I maybe I'll sit here so that it sees the camera, and
Yeah,
then
of
we should
course.
see it sort of pan past.
Yeah.
And then, is this an adequate distance right here?
Yeah, that's a good distance.
Okay.
Yeah, we just need to turn it on, and then we'll have to. Everyone else will have to hide.
Oh my god, it's kind of scary.
It said hello. It said hello. Yeah.
So it panned. It would have seen this edge, my left edge over here. It kept going until it saw the distance increase.
Yeah.
And then it went back to the middle of those 2 points and pulled the trigger. Very, very cool.
It's a little difficult to get right because we noticed that this laser sensor actually reads somewhat slowly, a little bit slower than the servo moves, and so we needed to sort of play with the parameters to get it like to fully center.
There was also the fact that the I2C communication on this was kind of broken, so we used its serial interface, and so it would send a. One of the problems we had was it would send strings, and it would say, "Oh, valid range," and then give the distance.
Yeah.
And parse that with scanf, and we do that. But then if it went from a small distance to a very large distance, it would say "signal fail," and so then the scanf would not work.
Okay. Very cool. Very sort of mechanically complicated.
Yeah,
this was the hardest part by far.
It's kind of a little bit like Lab 3. Wait, was it Lab 3?
Yeah, it's for sure.
Yeah,
like
Pendulum
yeah,
Lab.
you know,
Yeah.
it was really kind of difficult to
The
get right
software,
mechanically.
yeah, the software wasn't that hard. It was the parameters of the software.
Sure.
That was the hardest part.
And then there were a couple other things that we tried to implement. Like we originally interfaced an ultrasonic sensor, but then we realized it just wasn't as accurate as a time of flight sensor would have been. And we also tried to implement with some PIR sensors, but we just realized that the PIR sensors just weren't accurate enough to like
Sure.
properly, like, you know, focus into an area and target on something.
Okay.
They weren't reliable enough.
Very cool. Thank you guys.
Of course.